This is a quick video tutorial on significant digits. So significant digits show how confident you are in the precision of your answer. You're not going to take a value and give 7 or 8 decimal places if you're really only sure of the first one. So significant digits are how you communicate to other people which digits actually matter because you measured them precisely. And the way we do that, we have to have conventions so that we can write the numbers out without having to say it every time. So we have conventions that we use to communicate. So, how we communicate it. If we write a non-zero digit, we're confident in it. So if we put a non-zero digit down in an answer, then we're saying it's significant. If it wasn't significant, we wouldn't put it there. The second trick is zeros are confusing. Sometimes they are significant, sometimes we actually measured it and it really actually is 0 or rounds to 0. And sometimes zeros are just placeholders. I'll show you some examples of these things. So first, these zeros, in these numbers, the zeros are all significant. The reason we know that is, if we write down a non-zero digit, it's significant. So this one has to be significant because it's in there. We know that this is not 1, 2, 1, 5, 3 rounded to 0. It's 1, 2, 0, 5, 3, and we're positive that that is 0 in the middle of it. So that one's significant. These zeros are significant because we're lazy. If we didn't know these zeros, if we didn't know that they were actually zeros, why would we write them? Why wouldn't we just write 1.2? Because it's exactly the same number, just not as precise. So if we put the zeros after a decimal value, then we're confident of those zeros, so those are significant. The next one is here, same kind of situation. We have these two, by the last rule I discussed, these are significant. And they're in between, the remaining 0 is in between 2 non-zero digits, which are significant, and 2 zeros that are significant, so this must also be significant. And finally, if we have a number like 980, and we've actually rounded it, or we've actually measured, say, 980.3 or 979.8, and we're rounding to the nearest 1, so we know the answer is 980, well, that 0 doesn't follow any of the other rules that I've shown you on this page. So we have to have a way of communicating that that 0 is significant. The way we do that is with the decimal place afterwards. So if you see a number with a decimal after it, that is significant. A 0 with a decimal after it, that is significant. And if you write the answer, if you write 980 like this, then you're telling me it's actually only 2 significant digits. You've rounded to get that 0, or you've rounded to the nearest 10. But if you write it 980 with a decimal, that's your way of communicating to me that it is significant. These are non-significant zeros in these two numbers. This one, these 3 are non-significant because we didn't put a decimal place afterwards. So what we're saying is maybe it was 124,800 and we rounded to 3 significant digits, which means we're not sure that all of these are actually 0. In fact, when we calculated it, that's an 8, so it might not be 0. So on this side, all 3 of those zeros are non-significant. On this side, these zeros here are also not significant because this is the value we measured. These zeros, all these zeros here do is tell you how far you're going to the right of the decimal place with those 3 digits. So I'm going to show you one last thing before the end of this video. I've got a couple minutes, or I've got about 60 seconds, I think. The easiest way to save yourself from worrying about these is to look at scientific notation. If we turn these two numbers into scientific notation, we get 1.25. If we don't need these zeros, we don't have to write them. We just put in our times 10 to the power of 5. If we wanted those 3 zeros to be significant, we would write 1.25000 times 10 to the power of 5. And we could do anything in between. If we wanted it in 4 significant digits, 1.250 times 10 to the 5. And this is an easy way to tell if some digits are significant. If you transform the number into scientific notation, do you still need the zeros to communicate the value? On this side, same thing, 3.52 times 10 to the negative 2, 3, 4, 5, 6 is the same number, but all those zeros vanished because they're only placeholders. So they're not significant. So this has 3 significant digits in it. This also has 3 significant digits in it. All right, thanks for watching.